Alright, I took the engine back off the 704 after it was looking so good, because I still have this rod knock issue. Don't know if I can fix it without buying new parts, but I'm going to experiment a little bit. So I got the bottom off, and I have a dial indicator here. It's on a magnetic base that's stuck to the side of the block, and a nice adjustable arm so I can put the indicator where I need it. Since this engine is fairly worn, the crankshaft is easy to turn. The part that has the most resistance to movement is the rings dragging on the inside of the cylinder bore. So I have the crank turned so the rod's about 90 degrees from the crank throw. And first I'm going to look at how much the rod moves. And it looks like about 1/1000th of movement. I expect most of that comes from the clearance around the wrist pin. If the rings are sloppy in the piston ring grooves, there may be some movement in the piston. The rings are actually what's trying to stay in one place. So there's about 1/1000th of an inch movement there that I need to keep in mind for the next test. So I'm going to move the indicator over to the crankshaft throw and see how much the crankshaft moves. Now that looks like about 9/1000ths. That's a lot more than I expected. And I haven't even taken it apart yet, so there's going to be a little bit of oil film in there that may restrict the movement slightly. So what I want to know is how much movement the crankshaft has in the rod. So I have to subtract that 1/1000th of rod movement from the 9/1000ths of crankshaft movement. So you can figure there's about 8/1000ths worth of movement of the crankshaft inside of the big end of the rod. I'm in the other part of the shop now, so you get the furnace for background noise instead of the traffic going by. So I took the rod cap off here and got things cleaned up. It looks like it's about 2/1000ths out around with less than a 1/2,000th taper. So that's worn way out of spec, but I'm still going to try to improve it. I wiped the oil off of the connecting rod and the crankshaft. I'm going to pull the connecting rod up to where it's touching the crankshaft. This is Plastigauge. That's the brand name. And it's basically a long, skinny piece of wax that's made to a precision diameter. This front side shows metric measurements, so I'm going to use the back side where it's measured in inches. So I'm going to cut a piece off here. And I'm going to lay it straight across the crankshaft. So the theory is, the less space you got in there, the more it's going to squash it flat. Then you can use the gauge that's printed on the wrapper and see how much it got squashed. You need to make sure you don't turn the crankshaft, so it would kind of smear it around in there. And you like to torque the bolts to the proper torque. and then take it right back off again and see how much it squashed it. Now if I loosen this with my wrench in this position, I might break the oil dipper off when it comes loose. So I'm going to move to this side. Well, let's see what happened. If it was as wide as that first red line, it would be 6 thousandths thick. And it's not that wide, so the clearance is more than 6. It's hard to estimate how much more, because it's not a linear scale. That is, the change in width between 6 and 5 thousandths is a lot less than the change in width between, say, the 3 and the 2 thousandths. They make this stuff in different sizes, but I don't have the size to measure that larger gap. I said this was made of wax earlier, but I don't know what it's made of. I just know when you pick it off of there, it feels like wax. Looking at the specs in the Kohler book, here's where it tells the rod crank pin maximum clearance, and that's 3.5 thousandths. The test with the indicator that I did is the most reliable measurement, and it said there was about 8 thousandths clearance. So I'm going to try to reduce my clearance by about 5 thousandths. Another measurement that I want to take, so I have a starting point, would be this depth measurement in the rod cap. I modified the center pin in this depth micrometer years ago so I could measure the depth of narrow grooves and things, and it works good for measuring the depth of this rod cap. So that's just a hair over 575 thousandths. One way to remove metal from something is to use emery cloth on top of a granite surface plate. The main problem with doing it by hand is that you won't be able to keep your new surface in the same plane as the old surface. So you need some mechanical help for stability. So I'm going to make something that has 2 legs sticking out as far as they can and still stay on the same surface plate. And then I need to attach it to this rod cap to hold the rod cap in position. So I need a good way to position the cap relative to the rest of the device. And I'm going to use this indicator holder. It's made to hold your indicator in the drill chuck or collet of a milling machine. And by loosening this one knob, you can float it into position and tighten the knob where it'll stay. First, I need a way to attach this indicator holder to the rest of the device. So I made that out of a scrap piece of hex stock. It's got a hole in it that fits over this indicator holder, and another threaded hole so I can put a set screw in there to hold it in position. I'm going to use a nylon tip set screw so it doesn't mark up the indicator holder. Here's all the pieces I'm going to use. I have 2 long rods here that'll form the legs. They'll connect to this short section here, and the piece of hex stock will be welded to the other end of the short section. I put the long rods in the lathe and rounded off one end and sanded them smooth so they can slide on top of the surface plate without digging in. I'm ready to weld the legs together. They're spread far enough apart to be stable, but not so wide they'll come off the edge of the surface plate while I'm moving it around. I'm ready to get started here. I have the rod cap clamped to the indicator holder. I'm going to loosen the knob here so everything can move. And I'm going to hold the rod cap down tight against the surface plate and then tighten the knob. As you remove material, the whole thing's going to pivot downward, and the pivot point is where those two legs touch the surface plate. So in reality, it's going to remove a little bit more metal on the part that's towards me, because that's the part that's farthest from the pivot point. So all I can do is make the thing as long as possible to minimize that effect. I need to point out that I've never seen this recommended any place by anybody, so I can't promise it's going to be successful. I do know that on my 1934 John Deere Model A tractor, where the bearings are made with Babbitt material and molded to the rod and cap, they use shims between the rod and cap, so that as your bearing wears, you can take out shims to restore a good running clearance. So that's where I got the idea. And remember, my crankshaft is 2/1000 out of round, so I don't know how long it's going to last. Well, that took about 3/4 of a thousandths off. I need to remove 5/1000ths. So I'm going to change from 320 grit emery cloth to 220 grit. I'm going to reestablish that the rod cap is flat on the surface plate, just to make sure I didn't move it while I was measuring it. Well, I've taken about 1.5 thousandths off, and I need to go to 5. So this is going to take a while. So I'll work on it off camera for a bit. I removed about 5/1000ths from the connecting rod mating surface. So I put it back together to check the progress and see how much farther I want to go. Since the crankshaft is out around by 2/1000ths, and the most worn part is at the top and bottom when it's in this orientation, this is one of the places where I need to check the clearance. I need to move the rod without the crankshaft moving, so I have the crankshaft held in place here with this V-block. That looks like about 6/1000ths. This time, with the crankshaft clamped solid, I'm using a lot more force to move the rod. So the piston and rings and everything is moving along with it. And I think that measurement represents the rod clearance. Now I have it set up where the rod is about 90 degrees from the crankshaft throw. So here I'm testing the rod clearance where the crank pin is not worn as much. So I'm getting about 5 thousandths total travel, minus 1 thousandths to allow for the piston pin clearance. So I think the rod to crank pin clearance is about 4 thousandths. Now I want to know what clearance I'm trying to achieve. The old Kohler book only listed a maximum clearance for the rod to crank pin. Here I have a page out of a newer Kohler book, and it says the rod to pin clearance for new parts is from 1 to 2 thousandths. I know that my crank pin is at around by 2 thousandths, so I'm going to try to make my clearance from 1.5 to 3.5 thousandths. That's as close as I can get to a good spec with a crankshaft that's 2 thousandths out of round. I know that the method I'm using to remove material from the rod might end up removing more material off of one edge than the other. So I'm checking the clearance with Plastigauge again, but this time I'm just looking to see if I get the same measurement all the way across the rod journal. And it does look like it's a little wider on one end than the other. I'm going to mark the side of the rod cap where the Plastigauge is the narrowest, and I'm going to put that edge of the rod the farthest away from the pivot point of my setup, so theoretically more material gets removed from that side. That should put the crank pin clearance closer to the same all the way across. I have the rod cap clamped in my fixture again, and the side that I marked is on the outside where I want it. The measurements I took with the dial indicator showed that I had from 4 to 6 thousandths clearance. I'm going to try to make that 1.5 to 3.5 thousandths. So I'm going to try to take off 2.5 thousandths. I think I took off 2.5 thousandths. So I got it back together again, and I'm going to check the clearance. I have the crankshaft clamped in place, so I'm checking the smallest part of the crank pin, and that looks like about 3 thousandths. When I rotate it to check the largest part of the crank pin, I have about 2 thousandths of movement, and if I subtract 1 thousandths for the piston pin clearance, I have about 1 thousandths of rod to crank pin clearance. So I took off about 0.5 thousandths more than I wanted to, but right now my clearance is from 1 to 3 thousandths. With everything put back together, the engine turns quite freely. I don't feel any binding when I move the rod around, so this is looking promising. Alright, I took the rod cap off and oiled it up, put it back on and torqued it, and I already made a gasket. Got the oil pan back on. Everything's back together now. Think I'm ready to go. I put oil in it. Still has gas in it. So let's see if it'll run. Alright, that sounds good so far. I'm going to let it run at that speed for a little bit. Okay, that sounds good there. Don't hear any rod noise. Now I can hear the lifters tapping, and I can hear the belt flapping against the belt guard. That sounds like normal. I'm going to stop it just to see how it restarts. I'm going to treat it like any Kohler that's warm and not hot. I'm going to set the throttle halfway out so the governor has the throttle plate open. And I'm going to set it to half choke. Well, that ain't working. I'm pretty sure it's got plenty of fuel, so I don't want to give it more choke, so I'm going to treat it like it's flooded. I'm going to push the throttle all the way in so the throttle plate's wide open, and I'm going to set the choke so it's wide open. Since that fixed the problem, I think my carburetor setting's a little too rich. I'm going to try to restart it again, but this time I'm going to leave the choke off, and I'm going to leave the throttle at the idle position. Well, I think I can call that totally successful at this point. All I can do now is get some runtime on it and see if it keeps going. So I'll have to do a future update on this tractor. Maybe next spring after I get some runtime on it. Well, that's as far as I'm going this time, and here's what it looks like. Looks like Jake found him a new chew toy. I'll let him play with it for a while. As soon as he starts pulling chunks off it, I'll have to take it away from him. Alright, that's it.